Hi everybody. In this video we're going to state clearly the language problem, the language roadblock, which is holding the whole of science in a state of fragmentation. Nature all works together, but we teach it in isolated university departments without a second thought. Something's wrong. Typical human problem. Something so simple, we all missed it. So now we need to go right back to the beginning of physics, which I'm going to say starts with Newton. Gravity. We still haven't got gravity right. I can say that with complete confidence because gravity is isolated from every other part of science. It's the only member of general relativity. That means something's wrong. Physics isn't consistent information. Something's wrong. We establish truth in a court of law by looking for consistent information between all the witnesses. But physics isn't consistent information. So if we haven't got the first bit of physics right, gravity, no wonder the rest of it, all of it, makes no sense at all. So let's fix that problem today. It's a simple communication roadblock. So if we go back to Newton and look at the language, gravity is called a force. But there's a problem with that word. If we look at classical mechanics, the word force needs physical against physical interaction. Levers, gears, hydraulics, in which we exchange force for distance or rotation or area. We swap it for something. Gravity, we've got physical matter and empty space. A completely different principle, so we can't use the same word for two different principles. So let's look at what we've got. Einstein starts to clear the problem up when he says gravity is not a force, it's a relationship. Between what? Let's say it. Between physical matter and space. Now, another problem. Isn't a magnet and a magnetic field a relationship between physical matter and space? Isn't the Earth's magnetic field a change in space outside the Earth due to the presence of the Earth? Of course it is. So we need the same description for them both. Now, Einstein comes up with the curvature of space. This is very important. Space seems to be just nothing. But nothing and zero have two different meanings. No thing, nothing physical. But if I take all the physical properties of my desk, which is positive and negative, they all add up to zero. So I've got to be very, very careful. Now, curvature of space-time. I don't know if those are actually Einstein's words. If you do, I'd really appreciate you tell me in the comments, did he actually use that? Or is it something that crept in later? Because curvature is the wrong word. There isn't any. The only curvature in gravity is in the surfaces of the models we make to make a ball roll into the middle. But planets do not roll in towards the sun on a curved surface. It's nonsense. So what do they do? Well, if everybody on the earth stood up and dropped an apple, it has to be an apple, doesn't it? They would all fall in straight lines down a density gradient towards the center of gravity. So we've got to talk about density and direction, not curvature. So if I have a planet and a body is moving by the planet, it starts to move down a density gradient, and at the same time it's got linear momentum, trying to make it go straight on. I've got two directions, one down and one straight on. It starts to curve between the two. And when they equal each other, the desire to go straight on, the desire to go down, it goes into a curved orbit, not because of a curved surface. Because there are two directions it's trying to go along at the same time. Now, I still haven't said what gravity is. It's the relationship between physical matter and space. And if there's a relationship anywhere in the universe, relationships need, by definition, an exchange of information. Physical matter and space can exchange information between each other. That's what gravity is. And instantly, I can use that definition to explain a magnetic body and a magnetic field. Compass needles align with the direction and density of the field. It's alignment with the field, not forces. It's the same for electrical body and electrical field. We already have the directions, what we used to call Fleming's left-hand rule and right-hand rule. So we've got that bit. So now we've unified a gravitational body, a gravitational field, magnetic body, magnetic fields, electrical bodies and electrical fields. Done. And what we've done here is revealed a pattern, a prime number pattern between 2 and 3, the first two prime numbers, the building blocks of arithmetic, a related pair, electricity and magnetism, that generate each other, working with a unique partner. Doesn't seem like much of a pattern, but it underpins the whole of nature, the self-assembly of every system in nature. If we go right back to the beginning, there's just clouds of hydrogen, and look inside, 1 unit of hydrogen, 2 up quarks related and a down quark. Protons can change into neutrons inside stars, 2 down quarks and an up quark. And that can start to make the elements. Proton, neutron, electron. And it doesn't stop there. It just goes on and on and on, all the way through biology, the solar system. That's another video we'll come to. Let's just clear up getting science unified on common language. So we've got the exchange of information as the agent of change in the universe. And that means we can use that cause of action to describe everything that happens in classical physics. We can also use it to describe everything that happens in quantum physics. An exchange of information. So the two different kinds of physics cannot be unified on common physics. They can be unified on common principle. Now the big problem with quantum physics is it starts off completely deterministic, the Schrödinger equation, and that collapses the collapse of the wave function into something unknowable. The position on the detector screen where a wave arrives as a point, unknowable. So I've got completely deterministic, unknowable. Now let's see that at the physical scale, because we've got the laws of chaos. This is not physics. They're nothing to do with physics. They're completely fundamental. They're completely separate. But every action requires an exchange of information between the parts of a chaotic system. So I've got classical physics, and then chaotic physics, knowable and unknowable, and it's just the same pattern as quantum physics, the Schrödinger equation, the collapse of the wave function. Now let's unify physics and biology. Is biology knowable and unknowable? Asexual, a complete replica of the parent. Collapses into the unknowable, whether it's going to be male or female, and that gives you an even distribution in the population. Same thing. Human behaviour. Surely not. Well, you're all familiar with this one. Male business suit. Female choices. Male sexual response. Just look, and that's it. Female choices. Male shopping habits. We all know this one. Predetermined. Female choices. Classical music. You play what's written down. Jazz. You play what you feel. Classical art. Surrealism. It's the same. Left brain, right brain. It's the same. A very good book by Ian McGilchrist, The Master and His Emissary. And he lays out all these properties for the brain, not realizing he's laying out a copy of everything else in science. Now, as soon as you unify all the different parts of science upon common cause of action, the exchange of information, we see a mathematical pattern that underpins all of nature, a principle, knowable and unknowable, and that means that we need to completely rethink everything we understand about nature. We now have a description of nature which is self-consistent, and that means something we can all hold as truth. Now I'm going to make a lot more videos showing you the complexity gradient of reality, how it's driven by mathematical rules which are not in any physics book. Physics just starts it all off. Then I've got the laws of chaos. Then I've got the laws of complexity, self-organizing systems. First is the solar system, and there's nothing in physics which can self-organize anything. So we really do need to start again. So let's just recap on what we've done. We've unified gravity with the rest of science, specifically gravity and electromagnetism. So that becomes general relativity, the general relationship between physical matter and space. And then we've got relationships between waves of energy and matter and matter, classical mechanics. That's just the same as the quantum. I've got properties, relationship between atomic units and space, relationships which bring the properties of mass, magnetic moments, electrical charge in 3 quantized units, -1, +1, 0. That's not the energy, that's the mathematical properties. The energy, the charge on the electron, the proton, is 1.6 times 10 to the minus 19 of a coulomb. So I've got two lots of properties, mathematical properties to consider, properties in terms of energy. So we really do need to start again on top of consistent language, which we can now do. As soon as you hear this, nobody can tell you that gravity is the curvature of anything. There are no curved surfaces in space. So we need to start again from scratch. And this video does that. I'll see you in the next one.